Okay, so we're told in this table that the number of prom tickets sold over a 10-day period is represented here, where X is the days we're looking at and Y is the prom tickets. Plot these data points on the coordinate grid below. Use a consistent and appropriate scale. Draw a reasonable line of best fit and write its equation. So let's start by just plotting these out. And I'm just going to say ahead of time, this is a great question for the graphing calculator. So notice the days go 1 through 10, right? 1, 2, 5, 7, 10. So the range is from 1 to 10. So down here on the x-axis, that's the pattern we're going to follow, right? 1, the first day, 2, 3, 4, 5 days, 6, 7, 8, 9, 10 days. So it's consistent. Every hop is one more day. And the number of prom tickets, let's check that. Our range there goes up to 70 and as low as 30. So I'm going to go up by 10s here. So we go up 10, 20, 30, and keep going by that increment. 40, 50, 60, 70, and I forget what I said already. How high did it go? Up to 70. Okay, so let's plot these points. Our first point, the day is 1, and the number of tickets sold is 30. So the point is 130, right? Because these can be represented as points. And then the next day, 2 is 35. So 2, here's 30, 40. 35 would be halfway there. Okay, day 5 is next at 55. So there are no tickets sold on 3 and 4. So 5 is at 55, right? So about here. And 7 is at 60. And 10 is at 70. So 7, 60 right here. And 10, 70 here. Alright, so a line of best fit is the line that best approximates these. And you could eyeball it and write an equation. But I feel like here, you're given the graphing calculator, you might as well take advantage of it. So they call line of best fit linear regression, right? Those are essentially the same things. And we're going to walk through how to do this on a calculator. It might seem tedious at first, but this is something that will really help you on these kind of questions. So the way it works in the graphing calculator is that you enter things into lists, all right? List of data. So we hit stat, and we want to edit our lists right here. You might have some data there already. All you have to do is go up to the heading, list 1, hit clear, and then press enter, and it clears the data. The same for list 2. We're going to use list 1 and list 2 here for days and prom tickets. Clear and enter. And then we just enter the data in, right? We have 1 day, and then I'll enter all the days in. 2, 5, 7, and 10. So we have those days entered. Now we enter the prom tickets. 30, 35, 55, and this will be confusing at first, but this really becomes useful. It's a time saver. 60 and 70. Alright, so we have the data points entered into our lists, and now we're going to have the calculator analyze this list. So we don't need this anymore. I'm just going to go to stat plots. And stat plot's up here, second y equals. So here's the stat plot. We want to tell it that we're plotting data into some kind of statistical analysis. It's on, and the type here I picked the scatter plot. My x list should be list 1, that's the days, and my y list should be list 2. And the marks here tell me the kind of data I'm going to be using. And then what I'm going to do, right, once you have this all set up, you can get out of here, second quit. Right, so now we just go to calc, right, so second, oh, sorry, no. We go back to stats. Now we go to calculations, and here you'll see it says linear regression, ax plus b. So a is your slope, b is your y-intercept. This is linear regression, choice 4. So now it's going to ask, what linear regression do you want to use? Well, I want to do the linear regression for those 2 lists that I set up. I hit second, list, select list 1, and there's L1, comma, second, stat, that's for the list, L2, so hit 2, and then comma, this is just a little confusing, but you'll hit the variables here equal, so press the vars button, y variables and function, select y1, you want to tell it what function to plot it as, hit enter. So here, what it's doing is it's giving you the line of best fit, and notice what the slope is. It's a, 4.537, so about 4.53, 4.54, and the y-intercept is 27.3148148. So here they don't really give you any guidelines to approximate, and I think it's a little absurd, but let's use this exactly. So you'd have this graphing calculator in front of you, able to take a screenshot of it to use it. So here, just gonna, or you could write this down if you're doing this, but I can't, so I want to be able to read this as I go. If they don't give you any parameters to estimate, and they don't here, be as exact as possible. Don't give them any room to take points off of your hard work here. So B is 27.31. So here's 20, 30. So that makes sense, right? The y-intercept is about there. And the slope is about 4.53. You can imagine it's almost 5 we're approximating here. So it's up 5 over 1, right? Up 5 over 1, and so forth. And we can just kind of connect the dots here. And here, my line of best fit looks a little bit off, so I'm going to fix that. The line of best fit should be somewhat balanced with the points that you have. So we have about 27 something here. And to go up 5 and over 1, I guess we should really go maybe here, right? Oops. Up 5 and over 1. Our slope is about 5, a little bit less than 5, so should keep that in mind, right? And I'll go a couple more here. Maybe like that. It's a better line of fit. So I was overestimating, right, a slope of 5 and jumping a little too high. The slope is below 5. So you can see how this fits those points better. Here you want to kind of draw an arrow on this line here to extend it in both directions. And write your equation. Y equals 4.53703737. Looks like it's repeating. X plus B, or 27.31481481. Looks like it's repeating as well. But this is your line of best fit. So we have it all set up, right? And you could have approximated that line of best fit and estimated the slope. But here, since they give you the graphing calculator, you might as well be precise. All right, hope this helped.